Hello students, good evening. So today we are going to deal with a new topic, that is regulation of kidney. We are going to see how basically kidney gets regulated and which part of the body are responsible to control that. So the first one, basically kidney is regulated by three things, that is hypothalamus, or sometimes pituitary is also given as an option. Technically they are interconnected. Second is your adrenal gland, but it is not directly associated. Basically it comes under renin, angiotensin, aldosterone system. Juxtaglomerular apparatus, which is again the part of renin, angiotensin, aldosterone system. RAAS for short. Let us begin with the first thing, that is hypothalamus. So hypothalamus is basically interesting region of your brain which also comes under nervous, that is it is made up of nerves or nuclei. Nuclei means group of cytons, which we will learn in nervous system chapter. And hypothalamus is also responsible to produce hormones, so it is endocrine as well. Okay, so let us understand what does hypothalamus do. Hypothalamus is responsible to produce a hormone. Basically it synthesizes ADH. Now what is ADH? Stands for anti-diuretic hormone. Now what is anti-diuretic hormone? To understand that, let us understand what is diuresis. Diuresis is basically a phenomena through which huge amount of water is lost through the body in the form of urine, or through urine. So this phenomenon is called as diuresis. There are certain components such as tea, coffee, etc., or any other caffeine content are examples of diuretic compounds. Examples of diuretic compounds. So basically, because of these compounds, a person experiences frequent urination and much of water is lost through the urine. So ADH works against it. Basically ADH prevents the water loss. So what is the main job of ADH? ADH is responsible to prevent water loss in a person. If something happens, Okay, if something happens to the hypothalamus or pituitary, even in pituitary there are two sections, that is adenohypophysis, that means anterior pituitary, or neurohypophysis. So here I am actually talking about neurohypophysis. Neurohypophysis. So this is that section of the pituitary which is responsible to store ADH. So what did we learn? That hypothalamus synthesizes ADH, whereas this synthesized ADH will be stored in neurohypophysis. So in neurohypophysis the ADH is stored. So even if it is not hypothalamus, the pituitary is even damaged, the effect will be same. And what will be the effect? Damage will lead to damage, or some kind of problem in these tissue will lead to a condition called as diabetes insipidus. It will lead to a condition called as diabetes insipidus. What is diabetes insipidus? It's a condition where a person experiences frequent urination. Person experiences frequent urination. Basically, lots of water is lost through this condition. It is little bit different from diabetes mellitus, where diabetes mellitus is the problem of insulin. Diabetes mellitus is the problem of insulin deficiency, not the ADH. So there are two types of diabetes, and we have to focus when it comes to ADH. When the topic is ADH, you should be understanding the concept about diabetes insipidus. Now, what is diabetes insipidus? Basically, it is the deficiency of ADH, or in other words, the person will be experiencing loss of water. Now, how does ADH work, or what does ADH do? ADH acts on tubules of nephron such as DCT and CD, collecting duct and distal convoluted tubule. It stimulates the reabsorption. ADH is responsible to stimulate the reabsorption of water, and to certain extent salt, but mainly water. So we need to remember water reabsorption is under the influence of ADH when we talk about DCT. So in the part of DCT there is facultative reabsorption of water is happening. Facultative reabsorption of water is happening. Now what is facultative reabsorption? It means conditional reabsorption. It means conditional reabsorption. If a person is low on water, that means the person's body doesn't have enough amount of water, the osmotic receptor of that person body will get activated. So osmoreceptors are nothing but the receptors of cell that detects deficiency in water and salt level. Deficiency or decrease in water and salt. This in turn gives signal to brain, that is hypothalamus, and thus the ADH gets secreted. Okay, so this was the first part about the regulation with the help of hypothalamus. Now let's move on to the next part, that is understanding RAAS. But before understanding RAAS, we will understand a small part which is present in the kidney, that is JGA. Now first, what is RAAS? RAAS stands for renin, which is an hormone. It is different from the stomach enzyme, that is renin, which has double N in it. Secondly, angiotensin, which is again another hormone secreted by liver. Aldosterone, a hormone secreted by adrenal gland and system. Okay, so before beginning with that, I would like to make nephron. So this is Bowman's capsule. This is PCT. The loop of Henle goes down. Then you have DCT, and the DCT get fused with collecting duct. Now let me make afferent arteriole. As you can see, I'm making afferent arteriole which quite lies just next to the DCT. It lies just next to DCT, or it at least passes through the DCT region. I would like to focus on this section. Just have a close look on this section. Okay, I'm going to zoom this section. So consider this as afferent arteriole. This is an afferent arteriole which brings the blood towards the kidney for the filtration. And this, let us consider as DCT. I have taken the cross section, and this is the DCT. Now there are certain cells present over here in this region which are associated with the afferent arteriole. These cells are referred as juxtaglomerular cells. What do we call these cells? Juxtaglomerular cells. They are responsible to produce renin. They are capable of producing renin. Actually, they produce prorenin and dump into the arteriole, but the renin is the activated form. So we are right now going to consider only renin. There are certain cells present in this region. Now have a close look. The portion which is not close to the afferent arteriole will have normal cuboidal cells, whereas The one which is associated or which lies towards the region of afferent arteriole has little elongated cells. They are also cuboidal type, but they are appearing slender in nature. They appear little stick-like or compressed. These cells are called as macula densa. Macula densa. Okay, let us understand what are these cells. I hope you have understood the diagram. Once again, I am revising it. Nephron is arranged in such a way that afferent arteriole passes through or nearby the DCT and then it enters into the Bowman's capsule. The portion which is near the DCT, it has certain special cells called as juxtaglomerular cells which are capable of producing renin over here, and it has a macula densa that is present in your DCT section, and it is arranged in such a way that only these cells are in close proximity with your afferent arteriole. Okay, I hope you understood. Now let us understand the function of these two cells. As I already mentioned, JG cells, that is juxtaglomerular cells, are responsible to produce renin, which is an hormone, whereas the macula densa of DCT is responsible to detect the change in pressure, the change in glomerular filtration pressure. Any kind of change in the pressure will be detected by macula densa, and then they will accordingly react. Both juxtaglomerular cells and macula densa, they are together referred as juxtaglomerular apparatus. They together are referred as juxtaglomerular apparatus. Now, the actual renin system begins over here, that is RAAS system begins over here. So suppose there is falling blood pressure. There is fall in blood pressure. Automatically this will affect glomerular filtration also. So there will be fall in glomerular filtration pressure. Okay, there will be decrease in or fall in glomerular pressure or glomerular filtration pressure. This change or this decrease will be detected by, okay, this will be detected by, just give me 1 second, fall, here also fall in blood pressure and fall in glomerular pressure. Okay, now this will be detected by your juxtaglomerular apparatus. So what happens over here, this apparatus will start synthesizing renin. Renin will be synthesized. This renin, which is right now produced and dumped into the blood as it is an hormone, it will travel and it will activate a compound. It will activate a compound called as angiotensinogen. Angiotensinogen. Now this angiotensinogen is an inactive form of hormone which is produced by our liver. It is produced by our liver, and this gets activated by renin. Renin will activate it and it will convert it into angiotensin 1. Now angiotensin 1 is a vasoconstrictor, but it's a less potential vasoconstrictor. Less potential vasoconstrictor. That means it will cause the decrease in lumen of blood capillary to increase the pressure, but it is not enough to increase the pressure. That is the reason we say it is a less potential vasoconstrictor. It cannot generate that huge change. So it has to be converted into, now angiotensin 2 has to be converted into some other thing, and that is it is converted into angiotensin 2. It is converted into angiotensin 2, and this conversion is facilitated by our enzyme which is secreted by our lungs, and this enzyme is called as ACE, that is angiotensin converting enzyme. So ACE is an enzyme which is secreted by our lungs, and it is responsible to activate angiotensin 1 into angiotensin 2. Now angiotensin 2 is more potential. Angiotensin 2 is more potential vasoconstrictor. More potential, and it is responsible to do two jobs. The first job is to cause vasoconstriction of renal arteries or renal blood capillary especially. And another job is to activate a gland called renal gland. It is a gland present on the top of the kidney, and there is a special region called as adrenal cortex. This adrenal cortex will be stimulated by angiotensin 2. Now what does happen when angiotensin 2 activates adrenal cortex? The adrenal cortex is responsible to produce a hormone called as aldosterone. It's a mineralocorticoid which we will learn in hormonal chapter. So aldosterone, after release into the blood, it acts on DCT and CD and brings about reabsorption of water and salt. Now what will happen if water and salt is reabsorbed into the blood capillary? It will cause increase in viscosity of blood, and thus the blood volume will also increase and the viscosity will also increase, leading it to the increase in blood pressure, and hence the final effect is the GFR and blood pressure increases. Even in vasoconstriction, the effect is blood pressure increases and GFR or GFP is also increased. I hope you understood what is renin-angiotensin mechanism, and this is how our kidney regulates. Thank you.